So now we're going to go ahead and talk about some of the code that we have been using from the ants forging simulation that we're trying to change and work to fit our mining operations. So first we're going to look at just the user interface tab, and there's only a few things that we really need to change here because a lot of the meat is in the other sections based upon the code. So just a few of the things, we were just changing things like the color here. Obviously we don't want the pheromone to be seen in the ants forging, it's blue and green, but for our particular model we'd rather it just be invisible, so for this case we just made it black so it would just blend in with the background because we still want it to be there because this serves for a communication between our different agents and how they can get from their natural resource back home, but we don't want it to be seen like in the ants forge. So if we go over to the ant Java, and another thing, we're going to go through as we continue to work on this and change everything from ant, obviously, to reflect the terminology and the word uses that we're going to be using for mine. So ant.java is going to turn into robots or mining Java, and we'll change everything to fit appropriately. So some of the things that we need to change here is the pheromone and how that acts. Obviously, it's not going to act exactly the same because there's going to be 4 different natural resources rather than just one food source. So we'll have to change some of that code there. And then a lot of what we have to change is on this ants forge Java. So we left the size of the grid alone, but we wanted to go ahead and change the home because we want, right now, the ants were starting kind of in the middle of the field. But for our particular simulation, we want them to kind of start in the top corner. And we can change this at any time if need be. Also, as you can see, we changed the diamonds here because we want them to go from the, right now they're starting in the top left corner. So we created a diamond where diamonds can be excavated at this particular location. And we're going to go ahead and add not just diamonds, but like we talked about earlier, we're going to add gold, coal, and copper. So that's the big next step, is to add the different natural resources. We also wanted to go ahead and get rid of the obstacles in this case. So that's going to be another big change we'll have to make. And then we can go ahead and just show what's been done so far with the code and talk about a few more changes that are going to need to be made. So if we go ahead and play this, you can see that we changed the number of robots to 20. And you can see that the food source, which used to just be a small dot, is now a large square, which represents diamonds. And when they finally find this, okay, you can see that one found it, so it's leaving pheromone. Obviously, like I said, you can't see it, but you can see that the ants are starting to form a line as they're being attracted to that pheromone, and they're going back and forth from the diamond. And eventually they'll all catch on that, and they'll start creating a shortest path back and forth. So what we're going to need to do next is create a mining. So you'll be able to tell where the individual robots are mining throughout the mine. And we'll also need to add more natural resources. And then a lot of the bulk of our code will be working on the workforce allocation and determining when and where the agents will go and how they're going to communicate with each other. So those are some of the next steps for the project.
In simulation versus real world, we know that in simulation there's some variables that do not count as in the real world. So we are going to be discussing some of the problems that we will see in the real world that inline simulation does not account. First would be that inline simulation accounts that robots will be perfect, that it won't have any failures at all. But as we know, real world, there's nothing such as perfect or 100% non-failures. Another thing is that inline simulation does not account for variables such as what happened when robots are lost within the mine. This is, let's say that robots will go into resources and they lost in the mine. Now, in a real world, the humans would have to go either to fix it or to retrieve it, and that raises a lot of problems such as health and all of that. Another thing is inline simulation robots assign depending on resources within the mine, and the following problems may arise. So let's say, for example, that one robot was, or a group of robots were assigned to go and retrieve copper that was in that mine. Now, when that copper is done, the real world have to consider what happened to those to those robots that were assigned to copper, do they get reassigned or do they have to come back home? Another thing is that for signal communication, how do robots recognize if they should go or if another already went, and if enough robots have gone after that particular resources? Well, as we had talked early, these robots will be communicating via signals. Now, if one robot sends signals, how do robots that are near that robot that sends signal should recognize if they should go or if enough robots have already left? So all of these have been some of the discussion that we've been discussing as we simulate our model and see the differences between the simulation and the real world.